dear learners, my name is Dr. Rajeev Mishra, and I am working as a associate professor in one of the Dr. APJ Abdul Kalam University affiliated colleges. In the previous lecture, we have discussed that drying or dehydration of any material, say by employing the solar energy, means removal of moisture from the interior of the material to the surface, and then remove this moisture from the surface of the material to the ambient. We also have seen that it is a complex heat and mass transfer phenomena. It is not as simple as we can think that if we put our product to dry, it gets dried. It's a complex phenomena, and heat and mass transfer takes place in this process. There are various designs of solar dryers. We have already discussed solar greenhouse dryers in details. We have discussed various advantages, disadvantages, and possible applications of greenhouse dryers. In this present lecture, we are going to discuss about another very important solar dryer known as solar cabinet dryers. I have divided the lecture in the following content. First, I'll give you the brief introduction about the solar dryers and cabinet dryers, and then different types of dryers we'll discuss. Direct type solar dryer, indirect type solar dryer, mixed type solar dryer, cabinet type solar dryers, and solar cabinet dryers. And we'll discuss some their advantages, disadvantages, and what are the various applications of these cabinet dryers. Drying is basically a removal of moisture from the food product by passing either ambient or hot air through the product. And we can say it is the heat and mass transfer solar dehydration process in which following factors are to be considered. If you want to study, if you want to make some calculation for any crop we need to be dried, then there are some parameters need to be studied. One very important parameter is the solar intensity of radiation. Since it is a solar dryer, then your crop or food gets dried with the help of the solar energy. So solar intensity of radiation is a very important parameter. Second, the ambient temperature. Third, the air flow rate or wind velocity. Ambient relative humidity. Relative humidity is also a very important parameter. Heat of vaporization. A specific resistance of product depending on the physical characteristics. Then the optimum drying temperature. That this optimum drying temperature, that it may be different for the different crops. First, before going for drying any crop, you must know the optimum drying temperature of that crop. When time to time you need to measure the drying temperature for that crop. And the chemical treatment. All the agriculture products, when harvested, contain large amount of moisture, which result in spoilage during storage. It is well known fact that agriculture products with high moisture are prone to fungal growth, damage by insects, pests, etc. In order to overcome these problems, various drying techniques have been developed. Depending on how the solar energy is collected and utilized to dry the products, various drying modes are there. Open sun drying and solar drying. Open sun drying we have already discussed in detail. And another very important is the solar drying, here where the solar energy is not directly used by the crop. So in solar drying, the open sun drying has been the age-old process of drying agriculture products and various food items. It usually requires a safe place to put or rather spread the product to be dried. The product to be dried is spread over a surface. The sun heats up the product and the surrounding air and the product gets dried. But the disadvantage associated with open sun drying are that there is no control over the drying rate and hence no uniform drying of the food product. In case of slow drying, since this process is very slow and hence there is no any control, and because of the slow drying, your material can be deteriorate, and the deterioration of food due to the fungi and bacteria takes place. When the food product is over dried, there is a chance for since there is no any control, so there is a chance for the over drying also. But when the food product is over dried, it results in discoloration, loss of germination power, nutritional changes, or sometimes a complete damage of the product. There will be considerable damage due to rain, storm, birds, insects, etc. also. There is a contamination maybe due to the dust, flies, etc. during the time of the drying. Since your product is exposed, open to the sun, there may be contamination due to the dust and flies. There are different recent technologies used for drying. There are vacuum drying, spray drying, heat drying, superheated steam drying, microwave drying, etc. In these systems, controlled drying can be done. But to run, again the problem is that, but to run such systems, fuels like coal, oil and natural gases or electricity are used, which in turn are very costly and not eco-friendly most importantly, and making the system complicated. The right answer for all these problems which we are discussing here is the solar dryer. And cabinet dryer is basically one of the solar dryer developed. It is the cheaper, easy to handle and effective means of drying, because using such dryer, solar energy can be used meaningfully. Solar energy being the renewable source of energy is abundant, available at free of cost, clean, pollution free and lasting for millions of years in future. But the only problem with the solar energy is that how to utilize it. It is available, but availability doesn't mean anything if you don't utilize it. So we can classify the solar dryers in basically three modes, like direct type dryers, indirect type dryers and mixed mode dryers. Direct type means where the direct solar radiation will be utilized. Indirect in type dryers where we use the indirect solar energy in the form of the heated air, and in mixed mode we use both this direct and heated air with the help of the solar energy. And further, these three types, direct, indirect and mixed mode dryers, are classified in natural circulation and forced circulation. Natural circulation means the air will flow with buoyancy, and in forced circulation we use some fan to forcefully flow the air, allow to flow the air. So direct type dryers we discussed. Direct type solar dryers exposed the substance to be dehydrated or dried to the direct sunlight. They have a black absorbent surface which collects the sunlight and converts it into heat. The substance that needs to be dried is placed directly on the surface for drying. These dryers may have enclosures, glass covers or vents in order to increase its efficiency. You can see this diagram. The solar energy falling on this glass cover will be transmitted through this glass cover. It is absorbed by the black surface, and the crop which is kept above this black surface, the heat will be transferred from this black surface to the crop. The temperature of the crops gets increased, and the long wave radiation which enters into the in this chamber cannot go out of this the glass cover, and your temperature of the crop increases, and the air which is flowing inside this chamber from the bottom will be go out as the hot air, and your food gets dried. So in indirect type solar dryers, the black absorber surface absorbs sunlight and converts it into heat. A vent allows air to flow across the hot surface. The flowing air gains heat as it passes over the absorber surface. The hot air is then made to pass through the substance that needs to be dried. We just use this cabinet where these crops are placed, and the air takes the moisture from the substance, thus dehydrating it, and is removed from via chimney. The direct type solar dryers also may have passive, that is natural circulation, or the active or forced circulation. You can see here this diagram from the sun, the solar energy falling first through this glass on the surface. It is absorbed by the surface gets heated, and the air in from the bottom of this plate, it is being heated by the heat transfer from this plate, and this hot air allows to enter into the chamber where the crops are placed, and your crop gets dried. In mixed type solar dryers, the heated air from the separate solar collector is passed through a grain bed, and at the same time the drying cabinet absorbs the solar energy directly through the transparent walls. And the schematic diagram of a mixed mode dryers is being shown here in this diagram. You can see that these two types of direct and indirect modes are being utilized here in the mixed mode dryers. These mixed type solar dryers may be passive or active. So these active dryers and passive dryers, on the basis of the classification, the integral, this is the direct type, distribution, indirect type, mixed mode dryers, these can be classified on the basis of active and passive mode of operation. So cabinet type solar dryers, simple cabinet type solar dryers is suitable for small scale use, is shown in the diagram here. The dryer consists of, we can understand with the help of this diagram, the dryer consists of an enclosure with a transparent cover. Material to be dried is placed on perforated trays. It is given here in this diagram. The solar radiation entering the enclosure is absorbed in the product itself and the surrounding internal surfaces of the enclosure. As a result, moisture is removed from the product and the air inside is heated. Suitable opening at the bottom and top ensures a natural circulation. Temperature ranging from 50 degree to 80 degrees Celsius are usually obtained and the drying time ranges from 2 to 4 days. Typical products which can be dried with the help of this cabinet solar dryers are dates, apricot, chilies, grapes, etc. So we can very easily dry these dates, apricot, chilies, grapes with the help of this cabinet type solar dryers. And another solar cabinet dryers are there. It is very simple, very easy to design this solar cabinet dryers. A simple solar cabinet dryer is shown in this diagram, and we can understand with the help of this diagram. It can be constructed by village artists using locally available materials. It is a small hot box usually made with wood having a length about 3 times. It is very important to note these dimensions, that having a length about 3 times its width to minimize the shading effect of the side panels. 1 meter in length and 0.3 meter width is shown in the figure. The sides and bottom of the cabinet are painted black internally for absorbing the maximum solar radiation, because you know that the black surface absorbs the maximum solar radiation. Of the solar radiation transmitted through the plastic or glass cover, we can use either plastic or glass cover as the transparent medium. Relatively high temperature of the order of 80 degrees Celsius was recorded in the cabinet dryers experimentally. The products to be dried are kept in a simple aluminum tray having wire mesh or perforation at the bottom. The trays are placed a few centimeters above the bottom in the assembly, so that the product can receive the solar radiation directly. This also helps more air easily to flow from the bottom of the trays through the product. So we can understand these things with the help of this diagram. Holes are provided. You can see large holes are here. So holes are provided near the base and the top of the rear vertical side, a few centimeters below the cover, to permit the exit of the air by natural convection. It's very important to note here that natural convection is occurring here. The ambient air enters the cabinet through holes at the bottom. Why these holes are provided, you can understand it from this diagram. Passes through the product placed at the wire mesh and escapes with moisture vapors through the top holes provided on the rear vertical side. The initial low cost and easy maintenance are the main features of the cabinet dryers. Why these cabinet dryers are superior? That it's initial low cost and it's very easy to maintain. So the cabinet dryers reduces the drying time about half compared to the open sun drying. You have to note it down that it reduces the drying time half as compared with the open sun drying. Also, we get the improved quality of the dried product, since your product is not directly exposed to the sun. So the product quality also gets improved. But the drying time is sometimes more and the efficiency of the dryer is low are the disadvantage of this dryer. Though it has the improved drying time as compared to the open sun drying, but it is at some extent it is a disadvantage that the drying time is not as high as we can expect. The first solar cabinet dryer was fabricated and tested by Loyand at the Brace Research Institute with a loading of 7.2 kg per square meter of drying area. So another important type of cabinet dryer is the active ventilated cabinet solar dryer. You can see here in this diagram, if electricity is available, it is cheaper to connect the fan to the grid compared to PV installation. Besides the fan, also an electronic controller may be connected to the grid. What we are doing basically, we are trying to improve the efficiency of this cabinet dryers. For that, we are doing some changes in the design. So beside the fan, can also an electrical controller may be connected to the grid, which is able to adjust the appropriate temperature by varying speed of the fan. The dryer is shown in this figure. In a PV powered system, the fan is directly coupled to the solar module. You can install a solar module at some place, and with the help of that, the electrical energy generated by the PV module, you can run this fan, working without an accumulator and load controller. Increasing solar radiation increases the module's output. Thus, the speed of the fan. This has the advantage of permitting a simple temperature control merely by appropriately designing the components of PV system, thus awaiting an additional control device as long as the system is suitably dimensioned. We have seen in the previous slide that there is this disadvantage with these cabinet dryers in terms of the efficiency, because it has some high drying time. So we are trying to reduce the drying time, try to improve the efficiency of these dryers. So we are trying to discuss some different types of designs. So how to design a typical cabinet solar dryers? A typical cabinet solar dryers for many research work was being designed and fabricated for drying fresh leafy and fruity vegetables having moisture content of about 50 to 80%. If the moisture content of the product is about 50 to 80%, then we can design a cabinet solar dryer. The performance of dryer is evaluated by measuring the following parameters: the radiation incident on the dryer, that is the solar radiation, because we are discussing the solar cabinet dryers. So we are going to use the solar energy as the drying medium. So solar radiation incident on the solar dryer which can be measured with the help of the insolometer or digital Surya mapping. Air temperature at various locations such as the surrounding temperature, cabinet temperature and the temperature of the chimney, which can be measured with the help of either the thermometer or by temperature sensors. Weight variation of food product to be dried with respect to time. It is also a very important parameter which need to be measured. The temperature difference between cabinet air temperature and surrounding air temperature, as well as temperature difference between chimney air temperature and cabinet air temperature, have improved a role in the process of drying. The drying temperature in the cabinet is adjusted by adjusting the hot air flow through the chimney. The design parameters are decided on the basis of the normal incidence of solar radiation to get maximum solar radiation inside the dryer, and airflow rate required for removing moisture at an appropriate temperature in the required time, retaining the nutritional value of the dried product, because at the end of the day we also have to maintain the nutritional value of the product. The latitude angle is 20 degree. The transparent glass cover makes with cabinet, due to which the solar radiation incident of the glass cover during the daytime is collected to the maximum possible extent, employing solar energy effectively. The angle will be the angle given for the location. That is the angle of latitude. We can use the angle of latitude in which you need to that inclination. The total volume of the cabinet, for example, is 0.3752 meter cube in a particular design, and volume of chimney is 0.01707 meter cube. These volumes are sufficient to dry the fruit stuff up 2 to 3 kg, which is uniformly spread over the surface of the steel mesh in the dryer. The drying also depends upon upon the ambient temperature in the cabinet and the chimney has a function of solar radiation incident and the air flow rate. The output hot air through the chimney was measured by usual digital anemometer. So now we can summarize this lecture as the solar drying in practice since the ancient times of preservation of food and agriculture crops. Farmers in India have normally very small land holdings and most of them are not well educated. These farmers have to face blood of market uncertainties. As most of the farm producers are perishable, a farmer can do nothing. If rates of the market fall, the processing of perishable farm produce to a processed food can be a very good alternative for such farmers. Farmers can earn extra money for value addition to the product. Solar dehydration is traditionally practiced for few varieties of farm produce and fish. Also, the construction of cabinet dryers is made using the local materials and exports. These are some of the very advantages, the good advantages of this cabinet solar dryers. The construction of this cabinet solar dryers is made using the local available materials. It utilizes solar energy effectively. It is cheap and easy to handle. The dehydrated sample is saved from the contamination due to fungi, bacteria in the cabinet dryers. The use of cabinet solar dryers is very useful, especially to the small farmers, and it creates self-employment in the rural areas. So in this we have discussed the cabinet dryers in details, how this cabinet dryers is important, what are different types of cabinet dryers, and we have discussed some advantages of these cabinet dryers. Thank you very much.